Hi everyone, we are now getting into chapter 2, and this is what lectures will look like from here out. So you should see the chapter 2 lecture document, the PDF file. Open that up if you haven't already. We're going to be reading through it together, and then when we get to practice problems, that's what we'll have here on this page, and we'll do those. So if this class was in person, this is exactly the way I do it. I post the lecture notes so everybody can have that, and I read through it in the class period, and then when we get to the example problems, then we would be doing those on the board. So same idea here. We're just going to be doing the practice problems, in another video, but it's all going to unfold the same way. As we do this, please, please, please be writing these solutions down as I do them. You write them as well, and that will be your lecture notes. There is a lot to be said about active learning, which occurs when you're writing, versus passive learning, which would just be something like listening. You really engage with the material and internalize the material much better when you do active learning versus just listening. So write all this down just as if we were in class. Okay, so let's go for it. Looking at the lecture document, our chapter 2 is descriptive stats. So descriptive stats are all about how statistics are presented in pictures typically. So there's the definition there at the top: the collection, organization, summarization, and presentation of data. So at this point, you think, our surveys or whatever they are, those things have been conducted, hopefully in a responsible, unbiased way, at least as much as possible. And now we have the data for the sample, and it's now time to present that data, organize it, summarize it, that sort of thing. Okay, so it says, after collecting data, we must present it as a picture. A picture allows us to see trends and patterns, and it certainly helps us to convey our findings to other people quickly and easily. So we remember there are two types of data, right? Categorical, sometimes called qualitative data, which is categories, and quantitative data, which consists of numbers. So we're going to begin with categorical data. So it turns out there's not a whole lot of options for presenting categorical data. There will be a lot of options with quantitative data. But starting here with categorical, really there's only these two. It's the frequency distribution, also referred to as a frequency table. And there's the relative frequency distribution. So let me read the definitions there. So the frequency distribution, each category name, and the number of subjects that fall into each of the categories. And an example is down below where you see that bar graph, and really a frequency distribution is just the technical name for a bar graph. Okay, so if you look at that example, birthplace of students, this is from a former statistics course of mine. I polled the class where they were born, and so there were four options. They could have answered San Diego. They could have answered California. That's actually the third option there. I don't know why it's ordered this way when the data got put together, but okay, San Diego, then California, but not San Diego, the USA, but not California, and finally the last one there is outside of the US. And those were the responses from that class. So we see 25 people there were born in San Diego. 5 people is in the second column in the US, but not California. Also 5 people, California, but not San Diego. And it looks like about 7 people were born outside the US. By the way, that bar graph was created in StatCrunch, which we will be using that sort of thing as the course unfolds. Okay, so there you go. Once we collect our data, we've got 4 categories in that sense, and we just create the bars appropriately. All right, there's also a relative frequency distribution, which would present exactly the same data, but instead of the frequency there on the left side, Instead, it would give a proportion. Okay, so we've got that coming up on the next page. Then I say either of these can be represented as a bar graph or pie chart. The picture will clearly show how the data is distributed across the categories. Okay, let me scroll down and we'll get the relative frequency version of that same data where students were born from that particular that class from that was a class of mine a couple years ago. And now notice the bars are all the same, but the vertical axis there on the left is now a relative frequency versus just frequency. And so what does that mean? So now we have proportions, or maybe it's more familiar if I say they're percentages, although they're in their decimal representation. So in San Diego, now it's not how many students from the class, but it's a proportion, right? And it looks like it was 60%, 0.6. And in the US, but not California, it's hard to tell, but maybe that's about 12%, 0.12. And probably about the same for California, but not San Diego. And finally, outside the US, if my guess would be that's about 17%, maybe 18%. Were born outside the US, or 0.17 if it's 17%. From that same class, I asked them their transportation, their main means of transportation of getting to the campus. And so you see pie charts now. These were created in StatCrunch as well. So let's look at it. It's the same information, but now one is a frequency distribution, the other is a relative frequency. So on the left there, as you look at the legend, right, what is the big green area is that they take a car that they drive. So a car driven by me, and you see the number next to it is 31. 31 people in that class drove to the campus, and they themselves were the one driving the car. The yellow is the second biggest. They take a car, but it's driven by someone else. So they carpool some way or another. And that looks like that was 5 people. And then you can see some people bike, some people take the bus. And one person from that class actually walked to the campus. So those numbers are literally the number of people who answered that from the survey. You see the same pie chart to the right, but now you see percentages. And so it's all the same categories. It's all the proportions are all the same, but now instead of how many people from the class, it's the percentage. And now it's actually represented as a percentage. That's the way that it's represented here, although oftentimes you do just see the proportion, which is the decimal version of the percentage. Okay, so let's get to practice number 1. And we'll do this together here on my paper. So it says 25 Army recruits were tested for blood type. The data set is, okay, so we'd refer to what we see there as the raw data. Though that is all the results from these 25 Army recruits on their blood type. So either it could be type A, type B, type AB, or type O. And they're not in any order. That's just the order maybe that the recruits, were tested. And so nothing's organized. It's in a nice 5x5 kind of a grid there, but otherwise all the data is just kind of splattered at us, right? We don't, so we don't know who is who, and they didn't even put them, kind of group them together like all the A's and all the B's. That we just get it like that. Okay, so in part A it says construct a frequency distribution, and then in part B we'll do a relative frequency distribution. Okay, so how do we deal with raw data like this? Let's take a look. So in number 1 here, okay, so here's how I'm starting. Let me just show you a little bit. So I listed each of the 4 blood types, type A, type B, type AB, and type O. And we're just going to count up how many were from each of these 4 categories. Clearly this is categorical data, right? Blood type. Okay, how many type A's are there? And if you just kind of go maybe across the rows, I see 1, 2, 3, 4, 5. There are 5 type A's. So I'm just going to note that. How many type B's are there? So 1, 2, 3, 4, 5. Are there 6, 7? 1, 2, 3, 4, 5, 6, 7. There are 7 type B's. Okay. Type AB. 1, 2, 3. Not very many. Only 4 type ABs. And type O. 1, 2, 3, 4, 5, 6, 7, 8, 9 type O's. And now, a good thing, a good kind of fail safe is to take the total of those and just confirm that we really did count all 25 of these Army recruits. So if we add 5, 7, 4, and 9, do we get 25? And if we do, we know we didn't miss anybody. Okay, well, 5 and 7 is 12. And then 4 more is 16. And 9 more than that is 25. Okay, so we know we didn't miss anybody. All right, well, now that we have this counted, we're setting ourselves up to do that frequency distribution. So here's what I've done, and well, I'm just going to show it to you. Here it is. Again, well, it's a bar graph, right? So what I've done, let me talk you through it. So there's going to be 2 axes, right? There's a vertical axis and a horizontal axis. On the horizontal axis, you'll list your categories. So we've got type A, type B, type AB, and type O. On the vertical axis, you'll need to create some numbers for how many times each one of these appeared. So I noticed that the highest frequency is 9. So I just went ahead and scaled mine all the way up to 10, just a nice whole number there, so that my highest bar would end up being at 9. Okay, and then I went ahead and I marked off 10, and then I marked 5 and 10 just to make it a little bit easier to read. And then I create a bar for each one. So A reaches up to 5, right? And some people like to shade these in. I kind of like to shade them in. Looks a little nicer. Type B, well, that goes up to 7, right? Okay. Type AB was the smallest. That was at 4, so I'm trying to line that up with 4. And type O was the biggest, up at 9. So there's the 9. And that's it. It's a bar graph. One thing we got to make really clear here, there need to be these gaps between the bars. Okay, and that's actually really important. That's not negotiable. There need to be these gaps so that it will not be confused with a different way to represent data that you're going to see a little bit later in this chapter. Okay, now here's the thing. I decided to list the categories as A, B, AB, and O. But there's no rhyme or reason to that. It kind of makes sense maybe alphabetically, but the categories don't have any order to them. You know, we could put the O first, and then the B, and then the AB, and the A, right? So the order of these categories does not matter. All right, let's look at part B. We're to construct a relative frequency distribution. So what would that be like? Well, we've done some of the work already. That is counting up how many of the different types there are. So let's take a look here. To start us off, we need to find the proportions for each of the 4 categories. And so to do that, we're going to do a little division. To find the proportion of each of the blood types, take the number of that blood type and divide it by the total. So I'm going to show you what I've got here, and I'm going to just end up showing you all of my work, but we'll talk through it a little bit at a time. So for blood type A, what's the proportion that goes with blood type A? Well, we know there were 5 type A's, right? Divided by a total of 25 recruits. Grab a calculator, that'll give you 0.2. And so you might think of that as being 20%, but typically we just leave it as the decimal 0.2. Okay, type B, what was the proportion there? Well, there were 7 out of 25. And so that gives you 0.28. And we'll keep going. AB, type AB, well, there were only 4 out of 25. That's 0.16. And type O, 9 out of 25, 0.36. And so we're going to create a bar graph. And you notice the bars all look exactly the same compared to one another. All that's changed is what's on this vertical axis. So now instead of how many there were, we give the proportion. So I decided, the biggest one I see here is 0.36. So I just decided to go up to 0.4 and marking off the halfway points all the way, and then 0.1, 0.2, 0.3, 0.4 makes it a little bit easier to read. And then when we create the bars, well, type A reaches all the way up to 0.2. Type B reaches up to 0.28. So it's not quite all the way to 0.3. It's a little bit short. Do your best when you're creating these by hand. I'm not looking for perfection, but communicate as best you can that that's a little bit short of 0.3. Okay, then we had 0.16. So that's 0.15. So it's just a little bit higher. Let me make that a little bit straighter right there. Okay. That looks a little bit better. All right. And then O is 0.36, so it's just a little bit above 0.35, something like that. Looks pretty good. And there you go. So, and of course, we have the gaps in between them. That's critical. Got to have the gaps. And there it is. Now, these take time. It may feel tedious, but we're earning our right to use StatCrunch later in the course, which will do all this sort of thing for us. And by the way, you're never going to be asked to create a pie chart by hand, only these bar graphs for relative frequency, frequency and relative frequency. Okay, let's stop this video here. More to come.